I've been working on developing a fully featured MCU-inspired Iron Man heads-up display inside of this helmet. For the first version of that helmet, I used the NVIDIA Jetson NX development kit, and it worked fantastic. And because of that, NVIDIA took notice, and they've decided to set me up with the brand new Jetson Orin Nano development kit that is coming out, well, the day that this video is being posted, hopefully. Just to let you know, I received this kit last Thursday, and this video is supposedly coming out on the Tuesday that it's released. So that is how long I've had it in my possession. In fact, I've only opened the box. I haven't even tried to set it up yet. But what I wanted to do real quick was go over the specs of this new board, tell you what's new about it, why it is even better than the board I have, and then, since I don't have a lot of time to go over all the different benchmarks that they've included, and because, let's be honest, a lot of the other YouTube channels are going to be covering all of those benchmarks, I wanted to do something a little different, and I wanted to see just how fast I could get this board unpacked, get it all set up, and then get my heads-up display running on this hardware. So, first things first, let's talk about the specs real quick. I'm not going to delve too much into them, but we are going to go through the list here. So I've got my trusty cheat sheet here that they passed along to me. Let's just run down this real fast, see what's new in this kit. To be honest, this thing has a lot in common with my Jetson Xavier kit in terms of the expansion ports, in terms of the memory, but we will go over what's different about this kit. So first of all, in the kit, you'll find everything you need to get going minus an SD card. You'll find the Jetson Orin Nano. It's an 8GB module. It has a DC power supply included, an 802.11 AC ABGN wireless interface controller, and it's going to include a quick start guide to get going. Now, this new Jetson module is based on the NVIDIA Ampere architecture as opposed to my Xavier, which was based upon the Volta technology. This one has 1,024 NVIDIA CUDA cores as opposed to my Xavier, which only had 384 cores. So if you're counting, that's roughly 3 times the CUDA cores to do really cool things with, and we're going to talk about those more in a minute. Now, the only real sort of downgrade I saw versus the Xavier was the 48 tensor cores my Xavier had versus this one, which has 32 cores. Don't know how that's really going to play in until I really get going with doing a lot of the AI handling, which I will be tackling in the future, but we'll see how that pans out when I get there. The 6-core ARM CPU, they don't list the frequency of the processor here, so I'm going to have to find that out when I get everything set up. But it's a 6-core ARM version 8.2 of the architecture, 64 bits. Again, a little bit different, a little bit lower than the Xavier NX. Only in the L2 cache department. Mine seemed to have a 6 megabyte L2 cache. The one that this one comes with has a 1.5 megabyte L2 cache, but everything else, I believe, is going to be pretty much the same. The memory on this one is, again, it's 8 gigabytes, just like I had on the Xavier, but this one is running a little bit faster on that memory speed. Power draw is going to be 7 watts to 15 watts. I think that's pretty similar to what this one, but obviously we're getting a lot more CUDA cores for that power. Expansion ports, very similar to the previous one. We've got 2 of the MIPI camera ports. They're a little bit different. They've got a different connector this time, but they should function exactly the same. We've got 2 M2 keys, just like we had on the last one. We've got 4 USB 3.2s. We've got a USB-C, but that's only for debugging and device mode. It's got the 1 gigabit Ethernet connector, and this one only has a single display port, a DisplayPort 1.2, where the Xavier had both a display port and an HDMI port. I don't think that's really going to affect me very much. For my purposes, I always run on DisplayPort. When I'm debugging, I've got my DisplayPort monitor back here, and the heads-up display itself runs off DisplayPort. So luckily, I don't think I'm at any sort of disadvantage there. Just talking about the performance, we're just going again off of their reviewer's guide here, but I did want to run past it, and we'll see how it pans out in the future when I get to there in development. They're saying that this has up to 80 times the AI performance of the previous Nano. Don't know where that really puts it with the Xavier. They're really just letting you know, they're comparing this kit to the previous Nano kit, which, as we already talked about, the reason I'm not really talking about the Nano kit in this video, the previous Jetson Nano kit that I had would not run my heads-up display. So that's why I'm not even doing a comparison here for my purposes for something high-end like this. I'm going from the Xavier NX to the Orin. That's why I'm doing that direct comparison there. Again, this is going to be a 40 tops of AI performance versus the Xavier, which had 21 tops of performance. So again, I think we're going to have a lot of extra overhead there. It says it has over 7 times the CPU performance of the original Nano. Again, don't know how that equates here. Curious to find that out. And they're saying it's 50 times more energy efficient than a Nano. Well, that'll be fantastic for me because, as you guys have seen before, I wear this on my chest and I carry around a battery pack. So all the energy savings I can have, I cannot wait to give it a shot. Anyway, just a ton of extra performance on this kit over the previous Nano kit. In case you were thinking about doing an upgrade, I am seeing a lot of numbers that give me a lot of hope that this is going to be a nice upgrade over my Xavier kit. So I do want to get this guy out of the box and get him onto the bench, but I do want to give you a quick overview of what I'm going to be doing here. So my goal is to get the new Orin Nano out of the box, get it onto the bench, get any of the peripherals that I need out of my arc reactor here. This arc reactor is housing my Xavier NX, and it was custom designed to fit that. I think that that's going to fit my Orin just fine. I'll find that out in the future, but I'm not going to try to get it housed inside of here. I'm not going to try to transfer everything over yet. I just want to get it onto the bench, switch over all my cables, any of the plugs that I need, just to see if I can get it running. I want to see how much effort it is just to switch from the existing platform and just get it running on the Orin. As you can see, I've got it running back here on this monitor. As you can see, when I move this around, the cameras are showing up. I'll give you a close-up of this before I shut everything down. But I have all of this checked into GitHub where I can just pull it back down to the device. I'll see if everything builds once I get all of the libraries that I need installed. Kind of set a ticker, see how long this takes, and just see how well it runs. Let me pull you in close here real quick, show you the performance I have on here so that we may be able to tell a little bit about how much faster the new board runs. I do want to make one quick note. A couple of the things on my heads-up display aren't really going to port very well. First of all, my object detection, which I've had running on here forever, is not currently working. When I upgraded to the new Jetpack, which is NVIDIA's suite of libraries and everything, since then, I haven't been able to get that compiled and working again. That is on me. Not NVIDIA's problem, except that they changed something in the interaction of that library, and I just have not had a chance to get it going again because I've been working on other parts of the heads-up display. The other thing is they've already let me know that the NVIDIA hardware encoding is not working for the H.264, which is what I use on here to capture my video. They did say, of course, you can use X.264 software encoding, which we can take a look at here real quick because I did go ahead and write the code to do software encoding, and we can see, do we get any performance speed up on that new processor versus the processor on here. I will tell you on this, I don't think software encoding really it's not going to work. It's really slow, but I'll show you it. But I mean, after all, the reason we're running NVIDIA is because we've got all those CUDA cores to use, right? So let's take a look at what I've got running here. All right, so I've got everything up and running here. Let me show you how it works. Again, I've got dual cameras on this helmet, left and a right eye. And as you can see, this is a real-time heads-up display. As I move my hand, you can see it on the screen. And really, really responsive. So let me show you what I've got here. What's really important, as you can see, everything moves as I move the helmet. The display moves as it should. I have tilt here. I've got tilt here. Everything works just as expected. Got GPS running on here. There's a GPS in the top of the helmet. Usual things, time, compass. So as I move around, you can see the compass. But from a performance perspective, let's talk real quick. Down here, I'm showing my average frames per second, and I'm topping out real close to 120. That tops out ultimately because it starts throttling due to lack of power. There's still some power things I don't have quite figured out on the Jetson, and so it'll throttle itself a little bit to keep from pulling too much power. We top out at about 120 frames per second when I'm not doing any VSync capping on this display. Now, when I enable the recording mode on here just by pressing R on the keyboard, that causes a memory copy to happen to be able to record this to the disk. And you'll see we take a pretty significant hit here. I'm curious to see exactly how this works on the Orin once the Orin's NVIDIA encoder is working properly. We take about a 50% hit in the average frames per second. We go down to about 30 frames per second, as you can see here, when we do video recording. Again, this is with the NVIDIA hardware encoding. If I stop that, we pop right back up to the 120 pretty quick. So what I'm going to do real quick, let me enable the software encoding, show you how that works on this hardware. We'll kind of gauge it as a benchmark. So let me go ahead and hit the R button. Let's take a look and see kind of how big of a hit we're going to take on recording. I hit R, and we're immediately dropping in our average frames per second. You can definitely see there's less frames per second here, and we'll see kind of where we drop to in the recording on average. We're dropping back down past 26 now, past 25, and the more I throw at this, the more I put my hand in front of it, it's really going to hurt that software encoder a lot more than what I ever saw on NVIDIA's hardware encoder. So at this point, you can see we're kind of dropping down to probably around 20 on average. Looks like with a lot of motion going, we're topping out at about 22, 23 frames per second, somewhere in that area. Definitely lower than what I'd want to walk around with it running on. 60 is ideal. Can't get to 60 right now just due to performance limitations. Some of it due to my code, some of it due to the hardware. When we go to software encoding, it's definitely going to take a big hit. So that's what we're seeing right now. I'm going to kill that right now. When we go back up to full speed, everything looks fantastic again. I guess all that's left to do is install the new hardware and see how we do. So looking at the Jetson Orin Nano developer kit, let's see what it comes with. We've got, they did pack an SD card, which has the OS and everything I need to get started on it. We'll put that aside. And here is the new development board. As you can see, this is my development board. I can't sell it. Not that I would ever do such a thing. I do have my expansion ports on the bottom here, and I will definitely be putting a solid state drive underneath here. I've also got my Wi-Fi adapter with the 2 antennas, and just as I was explaining earlier, this is the actual Orin module. I've got Ethernet, 4 USBs, DisplayPort, power, and that debug USB-C port, as well as the usual I/O pin headers here on the bottom, just as you would expect. See what else I've got in here. Again, this is the quick start guide. Shouldn't need that for this installation. I've got a power brick. This one is rated at 19 volts at 2.37 amps, so that's like almost 40 watts, I think, that this one can put out. Well, that's what the math says. We'll see how that pans out. And I think that's all I need out of here. There's also an American power adapter, but I already have one of those sitting here on my desk. Put this aside. Let's go ahead and get this thing set up. I'm going to take the SD card, the micro SD card that it came with, pull that out, and then that goes right here in the back with the contacts facing up. Again, hey, I did want to talk about it. It is 12:26 my time. Let's see how long it takes me to get up and running with what they shipped me. But I did get it. It does snap in. See right there. Let's get everything swapped over. So there's not a whole lot that goes into here. Let's go ahead and just get them over one at a time. I've got my display port, which goes right there. I've got only the USB port. The display port here is when I am going to the helmet for my display. Right now I'm just going to go to this monitor. So I need this USB here. That goes to the helmet sensors. I've got my USB drive here where I do all of my recording. I don't think I'll need that for this, although I will go ahead and put it in just in case I need something speedy to write to. Got keyboard and mouse. Now I am going to have to pull out here. These are the new connectors for my camera, as you can see right here. But they take a new wire, and I am going to have to pull out these HDMI adapters that I use in the cameras on my helmet in order to be able to pull those over. That's going to take a little bit of work to pull this out and get going. So let's go ahead and get going with that. Alright, I can take my old hardware off of here, set it aside. And I've got a couple of new CSI cables. It should work here. Okay, let me attach my RG cams on here. Okay. Let's get everything else plugged in. Let's get these back in here. They're labeled number 1 and number 2. All right, just plug it in, and if everything goes well, we will at least be to the power up point with everything connected. Oh, we've already got a fan. That's good. Display is initializing. NVIDIA coming up. Oh, that is high resolution. That's good. And now it's going to walk us through the setup here.
20 minutes later.
Ready to go. Okay. It took about 30 minutes from the moment I opened the box till I am up and running with a full desktop. That's pretty good. As the SD card came preloaded, at least for me, once you get one of these in your possessions, the SD card will only need to be imaged from the image that NVIDIA usually provides. So pretty quick setup and boot time here. So all I need to do now is get all my libraries installed, pull down my repo from GitHub, and try to get everything built, see how it runs. Let's see how fast that goes. I don't know if I'll record all of this because then I'll have to edit all of this. So I'll see you when it all gets set up. All right, so a lot of this Jetson Inference stuff took a long time to build. I think we're at about 2 a.m. here now, so this took quite a while to put together, but that's fine. One thing I want to see, this will actually test to see if one of my cameras are working properly as I run in here and actually test some of these binaries that it built for Jetson Inference, which can just run some sample like object detection for me. This is the same library that I was using for object detection in my code. So let's give this a shot. First time always takes longer to run.
A few moments later.
All right, so one thing I have to do have to set up my cameras apparently because it is not detecting them when I try to run the DetectNet code. So we're going to come into here. This is the utility that you can do to set up the 40-pin header. If you've got particular peripherals that's set up there, I do actually need to set up that for the arc reactor lights eventually. So everything should be set up now. I've got the two cameras set up and I've got inference installed. Let's see if we can detect net camera CSI://. Hey, that's what I like to see. Oh, well, it thinks that light's a toilet, but does it know I'm a person? Look at that. So that's running really fast at about 170, 180 frames per second. It's the smallest window, but it's definitely cranking away at that that object detection. That is freaking awesome. I love that. It's flipped over because the cameras do that kind of thing, but it is really, really speedy. Let's try the other camera. Let's make sure both cameras are hooked up correctly. And yep, that camera's working. So we've got good hardware. Let's see if if my software will compile now, or if I'm still missing any libraries. Let's go back over to my code. All right, let's make. Am I missing anything still? It's not looking like it. Okay. All right. Here kind of goes nothing since I've never run it on this platform. Everything's recording. This is for posterity. Let's do it. Graphics look good. Hey, check that out. It's working. Flying too. All right, so frames per second, we are at over 100. We're about at 150 frames per second on this. That is fantastic. You'll notice I don't have my GPS running right now. I don't have the key installed to access my Google Maps. That's fine. That's not what we're looking at here. It's not important. But you can see we've got 170 frames per second now. It is just flying. I've never seen it actually run this fast. So this is really good. Processor usage is relatively low from what I'm used to. It's at 60%. Memory usage, not important. They're both 8 gig systems. So I'm not really looking at that. It uses how much ever memory it uses, but it is really, really doing well performance-wise. It's actually a little bit better than I expected. So I guess what I really want to see here, I hope I don't run out of memory card. What I really want to see here is how does it do if I try to record? And I should be able to record with just a simple R. Again, I'm running at like 175 frames per second. Freaking awesome. Let's R. All right, it says it's recording. I drop down. How far am I going to drop though? And this is with software encoding. One thing I'm noticing is way more consistent than it was on the Xavier. It looks like I'm probably bottoming out at around 30 using software, which is where I was in hardware on the other system. So that's usable using software encoding on this platform. I very honestly did not expect that to be that smooth with software encoding. It wasn't. I mean, this is getting as good or just slightly better using software encoding than the Xavier NX was doing with hardware encoding, and it looks great. So here's what I want to do. All right, so it's been recording for a minute. I'm going to turn that off. Pops right back up to ridiculous frame rates. Let's quit this. And then I want to actually try to play that video back and see how it looks, because the smoothness of the playback tells me how well it was doing with the actual encoding. So let's do that. It did record. You can see my MKV file right there. I need to install a player. There we go. It is playing back. Once I start moving around, we'll really see how it looks. This looks really smooth though, as you can see right here. That is looking really nice. I want to zoom in a little bit. I'm going to start moving around here a little bit, and it can see me. Yeah, look at that. Software encoding working slightly better than my hardware encoding was working on the last platform. That's really impressive. And at 30 frames per second, it is still a usable helmet. In fact, that's what I was using the whole time when I did Dragon Con, or when I did it the whole time down at the Swanee Town Center. That was all at 30 frames per second recording. So this looks great. Let me try one more thing. So I did get the USB communication with the helmet working. You can see that here. That's working like it should. GPS is working. Again, still running at over 150 frames per second. I'm not seeing those power dips that I was seeing with the Xavier NX, which is great, which is probably why it's able to clock up so high. So that is fantastic. Now I'm going to do one thing they told me not to do, because they told me it will crash if I try to use the NVIDIA encoder. But won't hurt to try out, right? So I've recompiled it with the NVIDIA encoder for the video. Let's see what happens if I try to record. And it did exactly what it said it was going to. It crashed. But that's what was expected. So I'm going to run this one more time with the recording on. I'm going to move the helmet around a little bit, and we'll get one final shot here. So that about does it. It took about 2 hours. It's about 2:50 in the morning now. I was done about 2:30 getting everything running. So it was about a 2-hour complete switch over from the moment I unboxed it to the moment I had my software running on it. It's absolutely fantastic. It says a lot about the system itself. Once you install that SD card, once you've got that image, then get all of the various packages, libraries, Jetson Inference, everything that you need on there, then you're ready to go. I have shown you object detection was working with Jetson Inference. I need to fix my library so that my object detection works again. I'm still absolutely blown away that the software encoding is working on this platform. That says a lot about the speed of the processor. That says a lot about the speed of the GPUs as well, because that means that now I'm able to offload apparently a lot of the graphics over to the GPU. I'm running at 32, 33 frames per second with this encoding. I will, of course, put some of the encoded video in here for you to see, so that you can see exactly what the helmet was recording. And we'll record ourselves here. So it looks like I have me a new development platform. As of right now, I don't see any reason that I'll probably switch back to the Xavier unless I run into any bugs. Here we go. Everything's working great. Thank you, NVIDIA, for sending over the Jetson Orin Nano development kit. This kit's fantastic. This is the future of the Iron Man project. Again, thanks, NVIDIA, and I will see you guys next time. Oh, by the way, I'm Chris. This has been Kersey Fabrications, and it is almost 3 a.m.